Hi everyone, and welcome back to the chess video series here of designing a chess engine in Python. Today we are going to focus on uh, putting back in our valid moves. So where we finished off last time is we kind of broke it in terms of we put in restrictions on what moves were allowed from the user, and currently we hard coded in the move 6-4 to 4-4, row 6 column 4 to row 4 column 4, which is this white pawn move here, and no other moves are valid, and so the engine will not allow us to actually make any more moves. Now it's impossible to hard code all of the different moves in. Just by doing numbers like this, you would be a crazy person if you tried to do this, and so um, let's not do it like that. So first thing I'm gonna do is I'm just gonna get rid of that little fake move that we put in for testing, because we are going to write the white pawn moves first and foremost. Okay, so we have a function for it, which currently just says pass. So let's go ahead and code this. Now, you need to think about what it is exactly that we're trying to do here. So pawn moves. How do pawn moves on a chessboard? Well, these are probably the most unique moves because the black and white pawns actually move differently here. In all the other functions, they move the same. But white pawns always move off the board and black pawns always move down the board. And they can't move backwards. And so we have to consider that a little bit. Also, pawns can move twice on their first move, meaning the pawn actually has two available moves until it has moved. So we have to think about how we're going to do both of these things. Pawns also capture diagonally, meaning that you can't capture what's in front of you, but you can capture the two squares that are diagonally in front of you. So we're also going to have to consider that as well. So those are kind of our three possible moves for a pawn. One square forward, two squares forward if it's the first move, and then diagonally forward if there's a capture to be made. Those are all the legal chess moves that we're going to program. So let's start with the white pawns, and let's consider the row that they start on, so we know if they can move twice. Just to remind you guys, right? This is row 0. 1, 2, 3, 4, 5, 6, and 7. So the white pawns start on row 6. The black pawns start on row 1. And so if the piece is a white pawn and it's on row 6, then we should allow it to move both 1 square and 2 squares forward, assuming it's not being blocked. Obviously, if there's like another white piece here or a black piece here, it's not able to move 2 squares forward. So we also have to look out for that. All right, so let's get into it. So we're going to start with this simple idea of since the white and black pawns are different, let's start with that idea of, well, let's make sure that it's white's turn to move. So if it's white's turn to move, let's focus on the white pawn moves. So what do we want to do first? I think you could do this in a bunch of ways. You could do the captures first. I think it makes sense to start with a one pawn move. And here's why. If you can make a one square move, then you already know that the square in front of you is empty, which means you might also be able to make a two square move. And you don't need to recheck the square in front of you, or you already know it's clear. And so I propose the simple algorithm of first check to see if the square in front of you is empty, add that as a move, then check to see if you're on row 6 and the square 2 in front of you is empty, then add that move. And so here's what that algorithm looks like. So we're going to say if the board, the row in front of us, now remember we're doing row -1 here because we're going up the board. So we're decreasing the rows. White pawns are moving up the board. How do we know if a square is empty? Well, it's going to have 2 hyphens. Our double dash was our empty square. So this is just a 1 square pawn advance. So the square in front of it is empty, then that's a valid move. And so what we should do is we should append that to our move list. Moves.append, and moves is our parameter that we pass into each of these functions. So it's this empty list, and we're just adding moves to it, so that the computer knows, okay, if the user checks this move, then it's valid. And so we're going to say move, and then RC, because we're doing, remember, moves constructor right here, start square, end square, and the board. We need to pass those three pieces of information to it. So what's our start square? Our start square is RC. What's our end square? R minus 1C. And our board is just self board. Just passing a reference to that two-dimensional array. And the move class is going to handle the piece captured, the piece moved. It's going to log all of that information. Later on, we might even want to add in, if this is an en-passant move, or something like that, maybe some optional parameters, if it's a castling move, things like that, that we might have to come back in here and change a little bit. Right now, we're not going to focus on those things. They're a little bit tricky and require a little bit of extra thought. So now we have a one square move, and we're going to check to see, well, let's see if it's on row 6. And if it is on row 6, let's see if the row 2 in front of it is empty. And so now we're going to do this inside of the other if statement, because if the square 1 in front of it is blocked, then it certainly can't move 2 squares. So here, well, let's first check if row is 6, and if the square 2 in front of it, so R minus 2, is also empty. And so if this is the case, so this is a 2 square on advance, then we can simply add that as our move. And so we're going to append the move. Again, starting square, RC. And these are tuples that we're grouping, so we put these in parentheses. Our second tuple is our ending square, so this is going to be R minus 2C. And then our board. Okay, now if we just test our code right now, let's just make sure. And I'm going to ask you guys to try to do some of the other moves yourself. And it's a good idea to test your code as you go here, to see if if it's actually working the way it should be working. All right. And so let's just see, are the white pawns moving the way that we want them to? So let's try. All right, that didn't seem to work. Cool. So let's figure out why that's not working. So let's debug. The first thing I would try is, let's see what the moves are actually generating, to make sure that it's actually getting into each of these functions. So we want to see what's happening after pawn moves. And so what I'm going to do here is I'm going to go ahead and just print out moves. First of all, I want to make sure that the function that I think is being called. And so I'll put a little print statement there. And let's try it out. And yeah, it's not actually printing out the list. So this line of code is never being executed, which also means that this line of code is never being executed. And so I guess the question is, why is that happening? And so maybe we go one if statement in here, and let's just do a print statement test. I'm going to just print here. And again, I'm not seeing that print out in my console. So this is telling that the problem is with either this if statement or one of the if statements above. And we can test this out by printing above that if statement, and we do see that it's actually printing there. And so this is a good indication that it's a problem with this if statement logic right here. And let's just verify if turn is white and white to move, and there is the issue. This should be or, not and. It cannot be both white's turn and black's turn at the same time. And so we have found our bug. And now let's see if that fixed it. So now It looks like, yeah, it printed out a bunch of the moves. That's good. And now we can, yep. And now we can move our white pawns. And we can undo them. We can do 1 move and 2 moves. So everything looks like it's working now. All right. So if you run into an error, again, this is part of, writing code. Test it often. This is a good lesson. Like, you're not going to write things perfectly the first time every time. It's just not going to happen. So you write some code, test it, make sure it works. And if it's not working, fix it then before moving on. Don't let your bugs build up. Okay. So that's looking good. I'm going to go ahead and get rid of, I think I had a print statement here somewhere. I don't know where it was printing out the moves. It's printing out all the moves somewhere. I'm not sure where that's happening. So there it is. Okay, let's go ahead and get rid of that. All right. So we've got the 1 square moves, the 2 square moves. So what's next is the captures. So what does that look like for the captures? Well, this is our this is our right and left diagonals. So we can do similar. Now we're not going to be in the same if statement because sometimes the pawn can't move forward, but it can capture. And so we want this to be in a separate if statement. We want to make sure, first of all, that if we're capturing to the left, that we're not going to go off the left side of the board. So we want to make sure that column -1, so like capturing to the left, is greater than or equal to 0. We don't want to end up checking or going to column -1. This will either throw an error or will cause a weird bug where we're able to capture pieces since Python does -1 as the last element. This would actually make it so that you could capture from the left side of the board to the right side of the board. And that would be very, very weird. So we want to add that in. And now what we want to do is we want to check to make sure that there is a piece there. So unlike the last one, in the last one, we wanted to make sure that it was blank. In this one, we want to make sure that square that we're trying to capture, which is r-1, c-1, has a black piece there. Well, how do I know if that piece is black? Well, it should have its first character equal black. So there is an enemy piece to capture. And so we can go ahead and we can append our move. And at this point, I'm just going to copy and paste this because this is all pretty much the same. And we're just going to go ahead and do r-1, c-1. All the moves are constructed the same way. And there we go. So this should capture forward and to the left. And now capturing to the right. And so here we want to check if the column +1. Now, I don't want to do else if here. This is a mistake, actually, because if you do else if here, then it will only add 1 capture move, meaning if it can capture to the left, it'll just add this, and it will ignore captures to the right. We want to include both captures to the left and captures to the right. So these are captures to the left, and this should be captures to the right. We do want to make sure that this is less than or equal to 7, or we could do less than board or self.board.length or length of board. The row, something like that. But I think it's fine here to put in the number here. So if column +1 is less than 7, let's see, 7. Yeah, 7 should be less than or equal to 7. So we should only be able to capture up to the 7th column, which is our last column. So these will be captures to the right. And finally, now we'll basically just do the same logic here. R plus 1, or sorry, R minus 1, still moving forward on the board, but this time C plus 1, if the color of that piece is black. This again is our enemy piece to capture. Then we will append the move, but this time it's going to be R minus 1, C plus 1. Like that. All right, so how can we test this though? This is interesting, right? We can run it, we can make sure we don't have any syntax errors, but how do I test if I don't have a piece to capture? Well, until we add the black pawn moves, we really can't test this unless we modify the original board, which we actually have access to here. So I'm going to simply just add in a black pawn here into my grid. And you'll see that actually adds in a black pawn here. So we can actually test our captures. So here, first of all, let's test to see. Okay, so it's not letting me now move forward. So that's good. That's a good thing to test. It's not letting me move this piece at all. It is also not letting me move this piece. So we have another bug to fix. But that's okay. Let's go ahead and try and find it. Right. So if board R minus 1, C minus 1 is B, moves. Oh, there we go. Okay, yeah. The move starting square is always RC. I'm not sure why I did that. Some of you guys probably saw that when I was doing it and were questioning me in the video. Yeah, our starting squares are C, our ending squares are minus 1, C minus 1, R minus 1, C plus 1. That's some of the dangers of copying and pasting code. Sometimes when you copy and paste code, you don't think about what you're copying and pasting, and then you end up making mistakes like that. Now let's go ahead and try and test this. So here, okay, we can capture to the left. We can capture to the right. If we move a piece, that's all good. Cool. So it looks like our white pawns are moving forward, are being able to do captures, and that's looking pretty good. So I'm actually going to stop the video here because for an assignment for you guys, I actually want you guys to code the black pawn moves here. So here, if you can add in the else for the black pawn moves. And I would like you to try to finish this this function here, where you add in the black pawn moves. And I think this is a good exercise for those of you who are following along. And just I think this is a good time for the exercise. I'm going to actually also ask you to try some of the other moves as well: rook moves, knight moves, bishop moves, king moves, queen moves, and see if you can actually program those in yourself. And to get you set up for that, so actually there's one more thing I'm going to show you in this video. To get you set up for that, I think I want to show you a nicer way of doing this. Because right now we have if piece equals P, get pawn moves. If piece equals rook, get rook moves. And this is fine, but it's maybe not quite as elegant as it could be. And anytime you have a massive if statement, there's a data structure in Java called switch. Python doesn't have a switch, but you can use dictionaries to sort of do the same thing that a switch statement would do. If you'll notice, these are pretty common. These are pretty similar here. We check if the piece is lowercase p, if it's uppercase r, and we call a function, but notice the parameters are the same. So if somehow we could just change this here, then we would actually be able to just have one line of code that executes here. And so this is actually done in a pretty cool way that I want to show you. So I'm going to add this at the top, and I'm going to add this in the constructor because I only want to construct this thing one time. What this is going to be is this is going to be a dictionary called move functions. And essentially what this is going to do is it's going to map every letter to the given function that should be called when the piece is of that type. And this will prevent us from having to write 7 if statements or 6 if statements for the 6 different types of pieces. So we have P, and that key is going to map to the value of get pawn moves. And we're going to do that similar thing for the rest of them. R is going to be get rook moves. You don't need parentheses here. It's a little bit interesting here because we're just getting the name of the function. We're not passing the parameters yet. We'll pass the parameters later on. What else? We have the knight moves, so we can use n for that since that's the letter of the piece that we're using for knights. And this will be get knight moves. Now here's the thing, we don't have these functions yet, so we do need to add them in now. Let's do the rest of these first though. So bishop, let's add in get bishop moves, queen, get queen moves, and finally king and get king moves. So now each function is being mapped to, each piece is being mapped to a given function. And so what I can do now is I can use this dictionary called move functions down in my code to simplify this logic here, because you can imagine what this logic would look like if I wasn't doing this. It would be if piece is P, then get pawn moves. If piece is rook, then get rook moves. And it's not extremely long, but 6 if statements, it looks kind of messy. A much cleaner way of doing this is actually we can get rid of this if statement altogether now. And since we know the piece type here, we can just say self move functions, that field that we have there, of the piece, of the key value piece, which is going to be lowercase p, uppercase k, uppercase q, whatever letter of that piece. And it's going to grab the appropriate move function. And then we can just add in our parameters since they're all the same, RC moves. And this will actually call the appropriate move function based on piece type. Now, if you do run your code right now, you are going to get an error. And this is because these other get knight moves, get bishop moves don't exist yet. So I'm going to just put in skeletons for them. Like we did with the get rook moves. Let's just go ahead and copy this. So we have knight, bishop, I'm going to paste it, king, and queen. And then we'll just go back through here and we'll change each of these. So let's go ahead and say get knight moves and change this function to knight moves. Change this one to bishop. Change this one to king or queen. And then finally, we'll change the last one to king. So you just have to make sure you have one function for each of these. And right now, I think it would be a good exercise for those of you guys following along to really complete all these by yourself, or attempt to complete them all by yourself. And you should be able to, have an idea of how to do them based on what we did for the pawn moves. It's a little bit tricky. Some of them are a little bit tricky, but I'll kind of give you a pointer here to go through some of them. So obviously with the black pawn moves, right, then the big difference is they're going to be going down the board instead of up the board. So, what does that mean for the row? What row can move 2 instead of just moving 1? So you have to you can look at the white pawn logic that we used, make sure you put in the captures, things like that. But let's look at some of the other pieces. What about rooks? Well, rooks kind of move like pawns do, except they move so they can move up the board or side to side as many squares as possible. So the idea here of an algorithm would be move as many squares as you can until you run into a piece. And you have to check all 4 directions. So check going up? Is the square above me empty? Let's maybe load a different. I'm gonna go ahead and put a couple pieces in here just to kind of we'll add a couple extra pieces here so we can talk about them. Yeah, so for the rooks, right? If I'm looking to generate the moves for this rook here, right? I could start in any of the four directions, but if I start going to the right first, then I would go 1, 2. I would go to the right first, and I would say, okay, is column +1 an available square? And if it is, then I would keep going. Is column +2 an open square? And if it is, I would keep going. And so you might think, well, how do I do this? Well, it should jump to mind that a for loop or a while loop would be able to help you out with that. And you go until you hit a piece. And if you hit a piece and it's white, or if it's the same color as the piece itself, then that's not a valid move. But if it's opposite color, then it is a valid move. And then you should end your loop at that point in time. What about going to the left? Well, that's an empty square. That's an empty square. But how do I know to stop? Well, I've hit the edge of the board. So you also have to check. So you have to check two things. Have I hit the edge of the board, or have I hit another piece? And those are your two ending conditions. And then you just do that in all four directions. Again, if I hit my own piece, it's not a valid move. If I hit an enemy piece, that is a valid move and a possible capture. Bishops is a similar idea, but instead of going along the four rank files, cardinal directions, north, south, east, west, you're looking at diagonals. So you're going to decrease column by 1, increase or decrease row by 1, and that'll go up and to the left. Increase column, decrease row, up and to the right. And again, that same algorithm of move to that square. Is it empty? Then it's a valid move. Does it have a piece there? If the piece is the same color, it's not a valid move. If the piece is a opposite color, it is a valid move, and then end your loop. You might make use of breaks. If you're using while loops, that might work as well. There's tons of different ways to write these moves, so I want you to get a little creative with them and give this a good shot. Think about queen moves. Well, queens move in any direction, so they're kind of like a rook and a bishop combined. The queen move, actually, if you save that for last, should be the easiest one that you write out of all these move pieces. So there's a little hint for you. Knight and kings are a little bit different. So kings can only move one square, but in any direction. So that might just be best to just iterate over those 8 squares. And so maybe you want to make a list of the 8 possible squares you can move to, or the 8 possible coordinates you can move to, and then just iterate through those. That might be a good way of doing it. Again, checking to see if the piece is capturable or not. And then for knights, similar idea. There's 8 squares, and knights can jump over pieces. So you don't really need to worry about what's around them. You just have to worry about, is that square they're going to land on? Is it an enemy piece? Then that's fine. If it's an allied piece, that's not fine. And so, yeah, hopefully that gives you a good hint into how to start these. And I'm not sure about how many videos I'm going to do going through the actual moves themselves, because I really do want this to be an exercise that you guys do by yourselves and kind of figure out on your own. So yeah. All right, I'm going to finally wrap up the video now, and I will talk to you later.